Many meteorologists can point to an event from their youth that really got them interested in the weather. For me, that event hit close to home on this date in 1974. At the time, I was in 7th grade in Steubenville, Ohio, in the eastern part of the state. The previous day, an F5 tornado had devastated a small town named Xenia near Dayton in western Ohio. Half of that city's schools were nearly demolished, though fortunately the tornado hit after hours. But still, the news resonated in the halls of my school the next day. The Xenia tornado was one of an unprecedented barrage now known as the super outbreak, 148 tornadoes in 13 states in less than 20 hours. The first tornado touched down in Illinois around 1 in the afternoon on April 3rd. The last tornado around 8 in the morning the next day in North Carolina. Together, these tornadoes caused more than 300 fatalities and nearly 5,500 injuries. The total area affected was about 900 square miles. Remarkable, considering how relatively small tornadoes are. The surface weather map the morning of April 3rd, 1974, showed a strong 980 millibar low over Kansas, lots of isobars encircling it, indicating a large influence of that storm. By afternoon, the southerly flow of warm, humid air from the Gulf of Mexico ahead of the low had reached into the Ohio Valley, while a strong Pacific jet stream overhead with a pocket of fast winds over 120 miles per hour was carving out a deep trough over the southern plains. The satellite image showed a huge comma-shaped cloud pattern that's typical of powerful mid-latitude storms, but there were some breaks in the clouds in the Ohio and Tennessee valleys, and that allowed some sunshine to get through and heat the ground and fuel the thunderstorm development. Those thunderstorms actually organized into 3 distinct squall lines. You can kind of see that here, 1, 2, and 3. The middle squall line produced most of the strong tornadoes. The paths of the F5s are shown here as thick black lines, 2 of them in Alabama, 3 along the Ohio River, and then the Xenia F5 tornado. The dashed lines are the paths of the F3 and F4 tornadoes. There were plenty of those too. In fact, it wasn't just the total number of tornadoes that sets the super outbreak apart, but also the percentage that were strong. There were the 6 F5s with another 24 rated F4. 95 of the super outbreak tornadoes, about 2/3 of them, were rated F2 or higher. That's strong enough to demolish mobile homes and blow cars off the road. Only about 15% of the tornadoes were at the low end of the scale, the F0s. Now compare that to this breakdown of a more recent outbreak, May 3rd, 1999 in Oklahoma. In that tornado outbreak, there was only 1 F5 tornado, and just 17 of the tornadoes, less than 30%, were rated F2 or higher. Notice that almost half the tornadoes were rated F0. And that tendency for mostly weak tornadoes in an outbreak is much more common than what happened in the super outbreak. By the way, the F or Fujita scale has been used since the early 1970s to rate tornado damage potential, but it was recently updated. On February 1st, the National Weather Service began using the EF, or Enhanced Fujita scale. More on that in a future WeatherWise. Fred will be back with the extended forecast next.